Hello, I am Kamal Bhatia, Assistant Professor, ABES Engineering College, Ghaziabad. This is the lecture series for the subject Network Analysis and the Synthesis, and we are covering unit number 1, Fundamentals of Network Analysis. So the topic we are going to discuss is matrix approach of solving circuits. Till now, we discussed what is nodal analysis, what is mesh analysis of solving circuit, what is duality in the network analysis, and how source transformation approach is used for solving circuits. And today we are going to discuss the matrix approach of solving circuits. So what is the matrix approach? So matrix approach involves the easiest way to implement the mesh equations just by inspecting the meshes and the elements involved in it. So first of all, you need to inspect the mesh, remember, and the elements involved in it. How many elements are in the first mesh or second mesh or more? By inspecting the self-impedance or the resistance, you need to find the self-impedance and the mutual impedance or resistance. One can determine all the mesh current or the node voltage by using Gauss elimination method or the Cramer's rule to solve the equations. So this approach is basically used for the complex circuit having so many meshes. And let's check the procedure. The step one is determine all the self impedances in the circuit. That means impedance associated with only one mesh. Very important, this point. Step second is determine all the mutual impedance in the circuit. That means which are common among the meshes, which are common among the meshes. So now step three, determine the value of voltage matrix associated with the mesh. So what will be the size of Z matrix? Z stands for impedance matrix. Resistance can also be there in this Z matrices. So M by M means if there are two meshes, let's say, if there are only two mesh in the circuit, so 2 by 2 matrix will be there, will be applied for that circuit. So now using matrix approach, complete circuit can be represented by this basic equation of the Ohm's law, V is equal to I into R. We are representing this in the matrix form. You can easily note down this point. This is simple Ohm's law, V is equal to I into R. And we are presenting this Ohm's law equation in the matrix form, where Z matrix is the mesh impedance matrix and IM matrix is the mesh current matrix. So let's take one example. We need to find the current across all the resistances using the matrix approach. So we need to find the current using matrix approach. Using matrix approach, we need to find the current across all the resistances, 10 ohm resistance, 30 ohm and the 20 ohm resistance. So let's mark the direction of current and identify the mesh. How many mesh are in this particular question? This is, I'm taking first mesh I1 current in the clockwise direction, second mesh I2 current in the clockwise direction, same. So what is the number of mesh? Number of mesh is equals to 2. And I'm writing here Zm matrix into Im matrix is equals to Vm matrix. This is simple Ohm's law. So the Z matrix, if there are two mesh in the given question, the Z matrix will be 2 by 2 size matrix. Calling this equation number 1. Now we need to write the Z matrix. So I'm writing here what is Z matrix. We have decided the size of this matrix will be the 2 by 2. So I'm writing here Z12, sorry, Z11, Z12, Z21, and the Z22. So this is self impedance or resistance, these two, and Z12 and the Z21 are the mutual resistance or the impedance. So what is the meaning? We discussed just now what is the meaning of self impedance. Self impedance means impedance coming in that particular mesh, and mutual impedance means common. You need to know the word common and remember that common word. So the Zm matrix will be self-impedance. Impedance in the mesh 1, 10 ohm means resistance and the 20 ohm. So 10 ohm plus 20 ohm, this will be the Z11 because it is coming in the mesh 1. Now talk about Z12. Z12 means common or mutual. So this is 20 ohm. We need to write it as minus. This value will be the same minus 20 because of the direction. We are writing it as the minus. What is the value of Z22? Z22 means this is self-resistance. 2 and 2 means in the mesh 2. This was the mesh 2 and 30 ohm resistance plus 20 ohm resistance. So write down the 20 ohm plus 30 ohm. It will be the 50 minus 20, again minus 20. Sorry, it will be the 30. 30 minus 20, and this is 50. So we got the Z matrix of the size 2 by 2 because there was two mesh in this question. Now we need to find, I'm putting the value 30 minus 20 and the 50. I'm writing this value, and Im matrix will be the current I1 and the I2. And what is the Vm matrix? Vm matrix is 20 volt. And this first value is 20 volt. And the second mesh voltage is having opposite direction between the current and the voltage terminal. So I'm writing it as the minus 30. Important. You need to take care for this step. So this was the V1 in the mesh, voltage in the mesh 1, and this is voltage in the mesh 2. So now you can use the Gauss elimination method to solve the above matrix equations. You need to write the augmented matrix. You need to write the augmented matrix. I'm writing it here 30 minus 20 minus 20, 50, 20, minus 30. This is the augmented matrix. So what is the concept of these type of Gauss elimination method? You need to make any row element to 0. So I am trying to make this element 0 with the help of some row and the column combinations. So I'm writing it here, R2, applying R2 plus 2 by 3 R1. So these are the operation for the row 2, adding the row 2 and the row 1 and multiplying the row 1 by 2 by 3. So we can get this point 0, and this is 30. This is minus 20. This will be the 0. This will be the 36.66. This is 20 and minus 16.66. So remember, Gauss elimination method is you need to make this point 0. So I did it by the operations. What was the operation? This is hit and trial. You need to check this operation by yourself. R2 in place of row 2, I am using the operation row 2 plus 2 by 3 row 1. So now this question can be, we can solve 36.66 is I2 is equals to, I'm reading this 36.66 I2. Remember this one. So the I2. 36.66 I2 is equals to minus 16.66. I'm writing here 36.66 I2 is equal to minus 16.66. So I will get the answer in the minus I2 is equals to minus 0.45 ampere. And if we put this value into the equation 1, put I2 in this equation, means 30 minus 20, 20. Put I2 in equation 30 I1 minus 20 I2 is equals to this one, is equals to 20. So on putting I2 value, we can easily get the value of I1 is equals to 0.366 ampere. Remember the unit of the current. So with the help of matrix approach, we got the answers I1 and I2. We got the I1 and the I2 across all the resistances. So in 10 ohm, I1 current is flowing. In 30 ohm, I2 current is flowing. And in 20 ohm resistance, current is I1 minus I2. 20 ohm resistance. So this is the approach for solving the matrix approach to find the current or voltage. So let's take another question. Calculate the current across all the resistances using matrix approach. Remember, we need to find the current across all the resistances using matrix approach. So first of all, count the number of node. This is mesh 1. I'm writing here, this is mesh 2 and this is mesh 3. So number of mesh is equals to 3. So what will be the Z matrix size? We need to write the, first of all, Ohm's law, Zm into Im. is equals to Vm. This is simple Ohm's law. Vm is equal to V is equal to I into R. This is, I can write the Ohm's law. And what will be the size of Z matrix will be the 3 by 3. So let's find out the size of matrix Zm. We need to find the Z11, Z12, Z13, Z21, Z22, Z23, Z32, Z33, Z31, Z32, Z33. This was the 3 by 3 size matrix. And we know the meaning of Z11. The meaning of Z11 is the self resistances or impedances in the mesh one. So what is Z11? How we can find the value of Z11? 5 ohm, 15 ohm, 25 and 40. Add all these. 5, 15, 25 and 40. This is the Z11 only. Z12. 12 means in between 1 and 2 mesh. This is 25 ohm. This is 25 ohm. If this is the mesh 3, you can write anything. This was the I1, this was the I2 matrix, this was the third matrix, and the current flowing is I3. So minus 15 will be the Z12. Now Z13, in between 1 and 3, this is 25 ohm resistance. What is Z21 now? We need to find out the Z21. In between 2 and 1, again it is minus 15. In between 2 matrix, 0. Sorry, in between 2 matrix, Z22 means 10 ohm, 20 ohm and 15 ohm. 10, 20 and the 15. What will be the Z23? No resistance in between 2 and 3. Z31, let's talk about Z31 means mesh 3 and the mesh 1, 25 ohm. Minus 25 ohm. And Z32, what is the Z32 value? Z32 means in between the mesh 3 and 2, there is no common resistance. So 0. And Z33 means in the mesh 3, count 25 ohm, 30 ohm. So 25 plus 30. So we can write the Z matrix. We can write the Z matrix. Then IM matrix will be the I1, I2, I3. Then we can write it as the V1, V2, V3. The value of V1, V2, V3 will be we can write it as V1, V2 and the V3. And also we can write these values minus 15, minus 25. We just finished 0, 0, 25 plus 30, 55 ohm, minus 15, minus 25, 45, and this resistance I can write is as 85 ohm. So now writing the value of voltage minus 10, first V1 voltage. So how we are writing the V1? Let's look at how we are writing V1. V1 is 20 minus 30 is equals to minus 10. How we can write the value of V2? Check the mesh 2. Mesh 2 is having minus 10 volt source. How we can write the value of mesh 3 voltage? We need to write the 40 plus 30 plus 10. So 40 plus 30 plus 10, it will be the 80. So again, we need to solve this equation using Gauss elimination method and Gauss elimination method. We can easily find the values of I1, I2 and the I3. So write down the Gauss elimination matrix. Gauss elimination method, augmented matrix. In this, we need to write some operations. We know that 85 minus 15 minus 25 and the minus 15 minus 45, 0, minus 25, 0, 55. This is augmented matrix, minus 10, and the 80. So this is augmented matrix. Now we can write the operations here. So operations are row 2, R2 plus 3R1. These are the hit and trial operations. We need to regular practice while solving these type of equations using Gauss elimination method. So applying these operations, we can find the value of first I3 1.6 ampere, then I1 and I2 also 0.33 ampere, and the I2 will be the minus 0.118. So this is the approach of solving circuit using matrix method. So references from the book Anand Kumar, Network Analysis and Synthesis. Thank you for listening this lecture.